Hi, I'm Davin from the University of Staffordshire. I'm the Course Director for Games Technologies, and I'm joined today by
Craig Waitman, and I'm Senior Lecturer in Games Programming.
So today we're going to be talking about the three courses that fit under the games technology umbrella effectively. So that's the computer games design and programming, computer games development, and computer games programming. And we'll also touch on the foundation year as well that we offer here. But also we're going to talk about a bunch of other things that kind of makes staffs. So the facilities, industry, the placement opportunities that we offer, some of the learning content, and also graduate opportunities as well. So there are details if you do need to get in touch with us at a later date. Yeah. Okay, so here at Staffs, we are one of the biggest games education providers in the UK. We have around about 1,600 students in our Stoke campus and around about 200 in our London campus. But what that gives us is it creates a huge community of game developers here. And we cover things from animation, art, creators, designers, programmers, researchers, because we have all of these different courses that facilitates this disciplines. So with this, we also have a bunch of different facilities that kind of support the development of games, such things as like our mixed reality labs, where we have VR headsets all plugged in kind of into the desktops. We have mixed reality rooms. You can see there we've got the green screen kind of going on, so we can kind of immerse ourselves actually within inside of the games. We have a virtual production screen as well. So we can use things like what was used on the Mandalorian and all that sort of stuff. We do also have a motion capture lab as well. So it is a state-of-the-art, industry-ready motion capture lab where you can suit up, do your acting and recording, and put that straight into a game where you map it directly to a model. And all this is used by the biggest like games nowadays. So you have access to that, and you can use that. You can book that out for free. You can use it for any of your projects. We do also have a makerspace, so if you are interested in anything to do with actually tactile models, so let's say if you play Dungeons and Dragons, for instance, and you have a model and you want to go and print that out, you can actually print that out in the makerspace for really reduced costs as well, where if actually you're just paying for the material. But yeah, you can print those out and use, and that's all free to use whenever you want to. We do also have state-of-the-art equipment in all of our labs as well. So all of our games machines have a dual monitor setup. They have 3080 graphics cards, and the vast majority of them are 24/7 as well. They are all equipped with all the latest software that you'll be needed for the course, from all the premium licenses down to kind of some of the free ones as well. But you can kind of get ready to go with these. We do also have things like PlayStation 5 development kits. So you can build towards those, and if you're into art as well, you'll have Wacom tablets as well. So you can just use the graphics tablets to kind of draw whatever you want on those. So yeah, so as I mentioned, we do have some PS5s as well that you can use, so you can build your games to this. And actually, on the courses, you'll be expected to kind of interface with these hardware as well. All we do ask is that you sign the relevant NDA, but when we release the content to you. Okay, so moving on to the courses, that's obviously the main bit why we're here. We're going to have a look at programming, design and programming, development, and the Games Tech Foundation. So to begin with, games programming. This course is baked in a computer science background, but with the idea that you're creating applications for real-time software, such as games. So when you're making games, you need to really think about the optimization behind those. You need to understand memory and how to get things working really quickly. So obviously with a game, they tend to run about 60 FPS. Anything that we make needs to run 60 times a second. So we have to be really careful with what we do and kind of the algorithms we apply and all that sort of stuff. It's all built around C++, which is the industry leaning language for the games. And yeah, so let's have a look at some of the modules that are in this course. So this is the general course structure. I am going to pass it over to Craig to talk about these initial two modules, so computational methods and programming fundamentals.
Okay, thank you, Davin. Yeah, so computational methods and programming fundamentals are supposed to, well, as you can see, they run alongside each other. One of them focuses purely on the sort of computer science, sort of games adjacent computer science, and more theory sort of stuff. And in the other module, programming fundamentals, that's where you start to get your you start learning and start being introduced to C++. Okay, so within the games industry, C++ is the predominant language that is used, and so therefore we teach you that alongside C# in other modules to get you sort of prepared so you've got the correct language base. These two work together very, very well because in computational methods we will teach you how to do things more efficiently from a software sort of approach. So it essentially means that one of the examples I always throw out at this, at these things, and also on the course, is that it's little silly things like if you take a party that you're planning for 150 people and it's a seated party, so it's a wedding or something like that. And you don't throw at it anything that we might call a heuristic, so there's no guidelines there, so it doesn't matter. So, well, what's a heuristic? You might want to call it, well, these people like each other, so we'll put these people on this table, or these people don't like each other, so we won't be sitting them anywhere near each other. They're called heuristics. But if we don't bother with any of that, if we were to take every single combination of 150 guests and seat them sort of everywhere and pick the best combination at 1 a second, let's say, it would actually take us longer than the age of the universe, which is a phrase that is said quite a lot in this module, to actually solve that problem, because there's just a sheer amount of combinations just with 150 guests. So that's just sort of an example of this is clearly something that would need to be sped up. Now, doing it on a computer would clearly speed things up, right? But there's a lot of things that computers do, particularly when it comes to games, processing graphics, AI, that kind of stuff, that requires some savvy techniques and algorithms that will allow to speed these processes up. And combined with low-level techniques that you eventually learn throughout the course in terms of programming, this means that things can happen much faster. Okay, so that's ultimately doing things more efficiently, learning the computer science, learning algorithms, learning how things work within it from a computer science perspective. That's what the computational methods. And what's been observed, actually, whilst we've been running these two modules in the first term together, is that the sort of planning techniques and the pseudocode techniques and picking particular algorithms, that kind of stuff, that kind of bleeds over into the coursework in programming fundamentals as well. So students have been seen to be using the methods that have been taught in computational methods for the actual programming. So the idea is that you get that, okay, let's see how this works from a programming perspective, and then see it from a deeper theoretical perspective, and that gives us a fantastic sort of approach for the following two terms and indeed the following years. So yeah, it's a great combination in that first term.
Cool, thank you. And then moving on from those, so we've just introduced to you kind of more traditional programming, the lower end kind of things there, and then we move you on to a term where we're going to be looking at game engines. Specifically, in that first one, the C# scripting for game engines, we typically look at the Unity game engine. We introduce that to you, so you get used to kind of some of that like commercial software. And in mechanics prototyping, we actually introduce you to the Unreal Engine 5. Which means you are covering both of the two kind of primary engines that are currently underpinning a lot of the game technologies that you see out there today. So you'll be making multiple different games in these and understanding about game techniques, games programming, but also just a little bit of design, because even if you are going to be a programmer, you need to understand what actually makes a good game effectively, and kind of how we can start to put those systems together to make something fun, make something workable, and make something that players can really start to interact with. Moving on to term 3, we look at bespoke platform development and introduction to graphics programming. In introduction to graphics programming, we introduce you to a software called, an API called OpenGL, which is used to fundamentally draw models onto the screen, right? So as a programmer, the artists are going to give you their models. They're gonna, they're gonna look nice and fancy and all pretty and all that sort of stuff. But we need to be able to take those models and be able to render them to the screen. And we start to look at the fundamentals behind being able to do that. And eventually we do start in later years, we do start to look at things like shaders and post-processing and all that sort of stuff, which basically can really make your art shine, right? And give your games that unique flavor. You can do something really cool from it, like a tech art basis. In bespoke platform development, we actually make a game using an API called SDL, and we build it to a bespoke platform. So we actually have these handheld systems, and we build our games in Windows, and then we port them over to Linux effectively, and then be able to build them to our handheld system. So you're making a game for a bespoke platform. And with that, you get to learn all about the different programming techniques and understanding that just because we can make something on Windows work, it doesn't necessarily it's going to work on other platforms, and we look into those techniques as well around that. Moving into the second year, Craig, I'll let you talk about these ones again, if that's okay.
Yep, that's fine. Yeah. So did you want me to talk through the whole year there on level 5?
Just go for term 1 for now.
Yeah, term 1. So and I'll also add applied maths if you want for term 2.
Yeah,
because I take that one as well. So for multiplayer games programming. So essentially, this is building from the ground up, really, a networked game. So in this module, you'll take a framework that's designed in C#, and you'll be able to create a game. The objective here is to understand essentially how networked games work. So within when you're playing a networked game, you're playing sort of almost like a local copy of your game, which means things need to be synchronized. Effectively, you're playing a clone of the gaming world, that kind of thing. So broadly speaking, it's all the sort of technologies and understandings that actually build that kind of unified kind of experience. So we're working C#, and you also have this nice sort of graphics framework as well to work within. So we try to move people away from the classic games like Pong. Pong is a favorite that students try to do here, but we also try to get some more sort of creative games going on, and it also looks into things like prediction and that kind of stuff, so that you can minimize the amount of data packets that you send, which is also crucial within multiplayer games. So that's pretty good. With the real-time rendering framework, this sort of moves over from the graphics programming a little bit more. So we're moving over in graphics programming. We're looking into OpenGL sort of based kind of stuff. But in level 5, we're very much moving into DirectX. So it's here where you'll be dealing with the creating of 3D graphics within the DirectX framework and various different rendering sort of techniques there. And actually, taking that sort of lead into applied maths for games, which is the one you see in term 2 there. Once you've got that graphics framework together, that's kind of used as a basis for applied maths for games, because what we then do is we add physics to it. So the lovely thing about the physics module is that it teaches how to add the use of forces in your games. So sometimes you can see games where you press something and something happens, some animation happens, something like that. But for really effective sort of I guess games with emergent sort of behaviors, so you can have, say, two objects knocking to each other. So let's say you've got two cubes, just to simplify things, and those cubes then knock together and their corners knock together, and they sort of rotate because of that collision in the opposite direction, and they rotate off there into space, and maybe they're under the influence of gravity as well, so they'll fall, and you might have other forces. Well, it's essentially, how do we put physics, how we expect it to work in the real world, how do we stick that into a game? Because there are other challenges, it being a frame-based sort of technology games. So, and physics being linear as we tend to experience it, we need to make sure that things are doing what they should as each frame progresses, so that we're not getting sort of ridiculous results and springs aren't gaining energy, which sometimes can happen if you get these things wrong and that kind of stuff. So everything, if you've ever played an F1 game or any kind of game that relies on things like, I guess, ballistics or anything like that, with F1 games, it's things like sliding off a track, friction, simulated spring physics, all those kinds of things, and sort of torque and that kind of stuff. All of that is included in the applied maths for games, and that's another fantastic module. We get some really good stuff out of that. We get some students that sort of really push the boundaries on it and start going into things, more advanced maths. For instance, I'll just say it, Verlet integration. You might want to sort of research that perhaps if you don't know about that already. But I saw a response this year, for instance, in an assignment where someone had made a net and they could just generate spheres, and they filled this net with the spheres, and as they dropped the spheres in, the net would react with ripples and everything like that. So that was all under physics and mathematics. And if it got too heavy, the thing actually tore as well. So all the balls then fell through, and all the things that were in a mesh in this net, they became just frayed rope things at the bottom, and they also flipped around as well as they would into physics, and it was a beautiful simulation. So there's a fantastic load of things that you can actually do with that module.
Awesome, thank you. So that's moving on to the other module that kind of runs alongside this one, which is game artificial intelligence. So these kind of run parallel, kind of for a reason, because obviously we game AI is a bit mathematical to be honest. But in this module, we look at the three major concepts to kind of get you going with AI. That is steering behaviors, pathfinding, and decision making. So steering behaviors is where we basically apply force to our agents to give them a direction effectively to be able to go into, but also to be able to portray a particular type of behavior. So for instance, we may want to just have a simple seek, right? So move towards target. However, we might want to reverse that and have like flee from target. You can then be able to kind of combine these together. So we could be seeking towards one target whilst fleeing away from another target. But this gets really interesting when you then start to really combine behaviors. You can have something called like flocking, for instance, right? So we could have hundreds and hundreds of agents on screen that are all traveling towards a common goal, but are keeping together as a group. So we have group formation, but aren't colliding with each other and aren't interfering with each other. This sort of technology is used in films as well. So we actually saw this in the Lord of the Rings films. Moving on, we look at pathfinding, where we'll be able to analyze a map and be able to construct and calculate the best route possible for our particular agents. The most common known pathfinding system is A*, so we do take a look at that, but we also take a look at some others that surround it. So we talk about the optimizations that we can make and kind of the best use scenarios for different types of pathfinding systems. And then finally, we look at decision making, because all our agents need to be able to make decisions, and we'll look at multiple different types of architecture to be able to construct more complex scenarios. And you will, as a student, for your assessment, you'll be able to kind of decide which architecture you want to follow given the scenario that you want to be able to create. And then moving on to term 3, you'll see there we actually have started to introduce the optional modules. So this is the first time you're going to be able to make a kind of a choice on the course. And you'll see there that we have audio development, experimental systems, real-time illumination programming, and tools development. So just give you a kind of a brief rundown of these. Audio development is we look at audio systems in games and how can we kind of mimic those. So we'll look at foliage, background noise, sound effects, all that sort of stuff, and be able to implement them into a kind of our given scenario. Experimental systems is effectively virtual reality, augmented reality, and kind of just using different types of hardware to create unique experiences. Real-time illumination programming is effectively the ray tracing module. So it takes everything that you've learned so far in the other two graphics modules and be able to use ray traces to create some incredible lighting techniques. Effectively, so if you've been playing any the more modern AAA games, you'll have definitely have seen ray tracing in those. And tools development is where we uh, basically allow you to create a tool that supports the development of games. And this is quite an open-ended assessment where, as a student, you can decide what you want to do, what problem you want to try and solve, and the learning content is supported to help the students be able to create that particular tool. And this can be done in any language, in any engine, and we just really want you to understand why tools are important in the games engine, in games creation. And then the module that kind of runs alongside all of these optionals is called Junior Collaborative Games Development. And in this one, you partner up with all of the other departments. So the other programming courses, so development and design and programming, the art courses and the design courses to effectively make a game as part of a very large team. So this year we ran a team of 30 students, 30 students, 30 teams, all making games, and we get some really nice polished products out of this particular module. But also, obviously, you're going to understand how to work with other disciplines and how to project manage such a large project. With the exception of games programming, so you'll see where we get to development and design and programming shortly. This module actually also runs at level 6. So we have junior collaborative games development and senior collaborative games development. So you have the students that are running at level 6. Obviously, they've got a little bit more experience. They've gone through this module before. They act as kind of the leads on the team. And as a junior, you will be supporting that vision of the game kind of going through. I'll get onto why we don't do that on the games programming course in a moment. After you finish your level 5, you do have the option to do a placement year. This depends on things like your funding opportunities and all that sort of stuff, but you have the opportunity to kind of go to a placement, but we'll talk about placements in a little bit later. Moving into your final year with us, you'll see we have that big module there across the top called Games Development Project. We'll talk about that in a moment. But that runs alongside that. In the first term, you'll have low-level platform optimization, which is your introduction to those PlayStation 5s that we were talking about. So we effectively give you some bad code. It's code that doesn't work quite how we want it to do. And we ask you to first port that over to the console, but then also optimize it. So we really look into the depths of memory management and optimization techniques, just so we can make code that is quite heavily demanding run on very limited hardware. And in the next block, we have these optional modules. So we have advanced game artificial intelligence, advanced real-time graphics, advanced audio programming, and cloud-based multiplayer games development, which is effectively your master module for the relevant courses. So advanced games, artificial intelligence is Game AI Part 2, Advanced Real-Time Graphics is Real-Time Rendering Framework Part 2, Audio Programming is the Audio Development Part 2, and Cloud-Based Multiplayer Games Development is Multiplayer Games Programming Part 2. So this is where you take all of those skills that we've previously talked about, but you start to go more in depth and you become kind of more of a master of that particular craft. And obviously by the time you get to this point, you'll understand which one of those modules really spoke to you as a developer and as a programmer, so you'll kind of know what to go towards. Craig, am I okay to ask you to talk about the games development project?
Yes, I do love talking about the games development project. Thank you, Davin. So there's this is a great module. I mean, they're all great modules, but this is one of my particular favorites because this is the opportunity where you can extend your knowledge in a topic of your choice. So that might be something to do with advanced graphics. It could be something to do with gamification. It could be artificial intelligence. The one that I always end up wheeling out to this kind of stuff that happened a few years ago, really now, was the AI cats. I always mention AI cats. What AI cats was, let me just expand that a little bit, is there was a student that essentially wanted to model emotional behavior and to represent emotional behavior and mood within a gaming environment. With a view to, later on, obviously, this is interesting subject matter in and of itself, because if you can get externally measured emotional behavior going on, then you get more realism. But what effectively he had 5 of his own cats and he basically personality profiled his own cats, and he sort of encoded that effectively into a JSON file, and he uploaded it into his AI framework. So what did we have here? Then we had some digital representations of these cats, which is a 2D game. And what you could do effectively is you can these cats that had their own particular personalities, if they were particularly prone to anger, they would get angry at other cats. If there was one cat that was particularly skittish, it would not necessarily want to be around other cats, that kind of stuff. You might have a lazy cat, etc., etc. And also you could do things like throw them a ball of string or spray water at them and that kind of stuff, just to see how they would react, and they would react in different ways, right? So what that does, the reason I roll that one out is because it's not just about the technology, it's not just about the AI of it, although it was a big thing. The other thing is this particular student needed to research the psychological aspects of behavior and the psychological models of personality testing and that kind of stuff. And it was those models taken from psychology that he ended up basing his software on. Okay, so he could plot these personalities on various on the particular model that he ended up choosing from his research, and that really emphasizes the whole point of the development project, as you will do it in games programming, is that we focus on a piece of research that we try to get you to understand really, really well. And really, the point of creating an artifact, which is the piece of software that you might generate alongside the research, alongside the write-up, is that proves the pudding. It proves what you have learned. It shows the theory or the hypothesis that you're putting forward in your dissertation. And so it's a great module. What you do is you get given a supervisor. The supervisor is there to effectively project manage it, and also to direct your research, because it's very much student based. You go off and do your research. You meet every week. You come back. This is what you've done. Blah blah blah, and you have more discussions. And that's the point. You can just throw around ideas and that kind of thing, and it's a great little module for doing that. And what is it? It's the 40 credits, isn't it? This one.
Yes.
So yes, it's quite a big one as well. So yes,
this is double the size of all of the other modules, so it runs over the 2 terms. So you're afforded the space to be able to really get in depth with that research topic that you've ultimately chosen, to do all that research, create the literature review, but also to apply that into an artifact, into a portfolio-ready artifact.
Yeah, and you know this is the sort of thing that actually sells students the most, really. We'll talk about GradX later, but students can really show off their projects to potential employers when they come in and they see the work, and people have got jobs on the basis of their projects before, so it's really good. I mean, if you go to the other side of the spectrum and pick, say, gamification, I once had a student that essentially demonstrated that you could use gamification to teach the basics of programming, and it was essentially a game where he had a little scripting language inside the game, and you had to change variables. You had to go through various concepts like the use of functions, the use of selection, the use of iteration, and object orientation, to code your way to change reality so that you could solve the levels quicker. And it essentially taught the fundamentals of programming at the same time. So that was quite good as well. But yeah, great module that. Yeah.
Awesome.
Yeah.
Cool. And then the final module is where kind of the entire degree comes together, effectively. So you're put in a team with other programmers, and you effectively have to make a game engine where you bring in people that want to go do graphics, people that want to do physics, people that want to do AI, people that want to do audio, people that want to make tools, all that sort of stuff. And you work together to make that engine, and then you have to build an artifact effectively that will deploy to Windows and to other platforms such as the PlayStation. So you are really looking at a lot of really complex things that you have learned throughout the entirety of your degree to be able to make this really robust piece of software. And it's a module which gets a lot of good traction from industry. In fact, all of the teams in this module actually have an industry mentor that supports them every single week as well. So you have a meeting with an industry mentor to kind of support your development of this artifact. And in general, that is games programming. So we're going to move over to the other courses now. Next up is going to be the games design and programming. You'll see there's going to be some repeated modules, and we'll kind of just highlight those as we kind of go through. But so for games design and programming, this course is one that takes programming and design and kind of puts those together so you become knowledgeable in both areas. So you have a good understanding of what makes a game fun and how we can actually make that game. And effectively for this sort of role, you're looking at sort of like a technical design role. So you would be supporting the design team or the programming team to actually be able to make those like gameplay systems effectively. So here you'll see some of these course, like the course structure similar to like we just had. And if I just hit this for a second, so you'll see that for computational methods, obviously in program fundamentals, we've just done that one. They are shared with programming, and same for the C# scripting for game engines and mechanics prototyping, and then also for this introduction to graphics programming. So your first year shared quite a lot with the games programming students, but we do introduce you to this other module called games prototyping. In your final term, where in this module is where we introduce the concept of rapid prototyping of games. So you'll make a couple of games throughout the period of this term, and you will have to basically just try to find the fun in this unique project that you're ultimately trying to make. So we introduce a lot of rapid prototyping methodologies to you, talk about a bit of like small amounts of production kind of that goes in there, and all about kind of like how we can extract mechanics from games to ultimately try to make this fun experience. So that is your first year in games design and programming. Moving on to your second year, you'll see, with the exception of game artificial intelligence and this junior collaborative games development, these other three modules here are unique. And we have these optional modules here, which we've obviously just covered, and this tools development, which we've covered as well. So looking at these here, first up, we're going to look at C++ for engines, which is a module where you've already learned Unreal Engine from basics in this module here, this mechanics prototyping one. So here, we actually look at the C++ behind that engine. So we've taught you a visual scripting language in the first year called Blueprint. Now we're going to be looking at kind of actually programming behind the scenes for that particular engine and being able to kind of utilize the engine in a more technical way, effectively. So we go through kind of a lot of the systems, get ready to go to be able to create like unique behavior within inside of our games, optimizations, being able to make kind of tools, briefly looks at like artificial intelligence and all of that sort of stuff, all wrapped around in the context of Unreal Engine. So you are learning C++ and Unreal Engine in a combination with each other. Moving on to these two, because these kind of work in parallel with each other. So first we have this introduction to mechanics design and then advanced mechanics design. Both of these modules take a look at basically making unique mechanics for our particular games. In the first one, we introduce some of the more traditional mechanics that you'll find in games like shooters, like in like real-time strategy games, like turn-based games, like stat systems for your games, things like that, right? And we look at kind of how we can make those systems, or how we can also design them to make them fun and make them feel good. And we look at it into like player feel to really make them stand out and really make the games come together. When we go into the advanced mechanics design, this is where we kind of look at some of those systems, but we try to make it a lot more sort of like efficient. So we look at it from more of like the programming lens, effectively in here, and we look into things a bit like maths goes in here as well. One of the assessments that the students will do is we give you like a tanker model effectively, and you have to create the suspension for all of the treads and all of that sort of stuff that kind of goes in that. So it's an interesting part of the assessment. But we also look into a completely different programming paradigm in its entirety. So we look into an entity component system, so a more data-driven approach to programming here. as well. And so by the end of these two particular modules, you will have conceived some really interesting game mechanics, understood how to make them feel good, and kind of the elements that we need to do there to make them work within our games and make the games polished, but then also look at kind of the optimization behind those things. Moving on to this optional module, so this user interface design and implementation. If you've played a game, you'll have noticed we have user interfaces in our games, things that show health, ammo, mini-maps, way markers, that sort of thing. And we look at how we can actually make those things and make them work for our games, actually, and how we should be using these, like what type of UI we should be using as well for different scenarios, and how we can best convey that information to the player, because you've probably all played games where there's way too much UI going on, it gets lost and messy, but you probably play games where it's too minimal and you don't quite know what's going on. So we explore all those different options and instruct you how you can actually make these, you can convey all this complex information in a very usable way. Okay, moving on to the third year, we have the games development project, and here, Craig, I'm okay to get you just to kind of talk about these next three modules.
Yep, sure. So the multiplayer level design and multiplayer mechanics programming. So yeah, the multiplayer level design effectively is about taking what you would normally do as a single player, I suppose, and sort of move that over to making it effective. I guess when you could think of it as what I said about multiplayer games programming, where you're looking at how to effectively distribute a game across multiple users and that kind of stuff. But it's also about taking these multiplayer games and what would make an effective level design, for instance. So the thing with multiplayer levels is that, in more sort of advanced games, you can get zoning, whereby you've got entire servers actually, which will look after one entire area of a map, for instance. And one area of a map might be on one server, and you could have another area of a map on an entirely other set of servers, which is in a completely different country. But you wouldn't know it because you're driving your car from one zone to another, and effectively you've been ported over to a completely different server there. So that's the actual technology that's going on, but it's supposed to be supposed to be seamless, right? So again, it's that whole idea that that person that you can see running over there on a completely different server, but it's being sort of like ported over to you via data and that kind of stuff. So it's quite an interesting perspective, really, with the multiplayer mechanics programming. So that is focused on specifically a mechanic. Okay, so it's about something that has to be useful from a networking perspective. So that could be any mechanic within a game, but it can't be a mechanic you could potentially use within a single player scenario. It would have to be something that leverages the multiplayer sort of aspects of gaming. Okay, so that's what the assessment is entirely based on for multiplayer mechanics programming. So you can get all sorts of different sort of responses from that as well. There's also prototyping for technical designers. Now, this term technical designer here, excuse me, I've been coughing a bit when the mic's been off, but yeah. So with the prototyping for technical designers, this term technical designer, that's kind of how the job exists at the moment. I think in one of our meetings that I attended, which was an industry advisory panel, which, by the way, we do at least a couple of times a year. We meet with industry to find out, what do we need to do with our courses to keep it industry relevant, so that we're future facing and that kind of stuff. So you're very, very prepared for this kind of stuff. One of the people that was at that last meeting basically mentioned that, because the traditional game designer in industry doesn't necessarily exist anymore. They're all technical designers, right? So from a design perspective, it has to be from this technical perspective. And I guess from that, prototyping your game, using a game engine to prototype your game using blockouts and that kind of stuff, and making sure you're creating a vertical slice, for instance, of a particular game, which is a very, very detailed sort of a demonstration of a game prototype. You can also have horizontal prototypes, which gives you that very much top-down perspective on how the game is going to look, but not with very little sort of functionality involved. A vertical slice gives you a complete sort of part of the game that actually entirely works. So this is a very important skill. But this technical designer thing is essentially what games design and programming is all about. It's to create technical designers, people that can design, but also are very aware of how to use the games engines. They're very aware of how to use C++, for instance, from C++ for engines in Unreal, and C# within Unity and that kind of stuff. So it gives you that sort of nice, sort of all-rounder sort of perspective. Okay.
Cool. Awesome, thank you. And then the obviously we've already talked about like senior collaborative as well. Has been the jump to junior collab, and then the last one here is this low level gameplay. So this is where we kind of go back to just doing something a bit more traditional, so a from the ground up C++ application, but it's looking at the gameplay side of things as well. So you make a very very small little framework, and then you have to create a fun game with inside of that framework as well, understanding kind of the gameplay implementations of it and all that sort of stuff, all done in C++. Okay, so that is games design and programming. Moving on to our final 3 courses, which is games development. In this course, it is a technical degree, but you also look at different aspects as well. So you have things like visual effects in here, a little bit of modeling as well, but we also look at effectively making you a well-rounded developer to be able to go out and just make those games right. You can do that. So you'll have a look at the course here. So you kind of see with this, we kind of lie sort of in the middle there with this skill discipline there. So I'm just going to do what I just with the design and program one. So we program fundamentals, that is on all 3 courses, and so are these ones here. AI again is on all 3 courses, and C++ for engines is on the games design and programming, and the junior collaborative games development and senior collaborative games development. So obviously we've already spoke about those ones. And then audio development and experimental systems and user interface design. So these ones here are on all 3 courses, whilst this one here was just on design and programming. And yeah, so we'll go from here really. In fact, actually, prototype for technical designers, obviously we just talked about from design and programming, and advanced game artificial intelligence was also on the games programming course as well. So
I think we've also spoken about the tools development as well, Davin.
Oh no, that is a separate module.
It's a different one. Sorry, yeah,
so,
confused.
That's perfectly fine. So looking at games development then, so we have the module that runs alongside your introduction to programming, which is the introduction to asset creation. So here we introduce to you the basics of 3D modeling, effectively being able to work towards a brief, be able to make props for a level, that sort of thing. So the idea is that you are getting used to 3D modeling software and are able to model and texture, so you can create assets for your particular games. Moving on to term 3, we have the fundamentals of game development and production process and pipeline. I'm actually going to pass these over to Craig.
Yep. So I actually take the production process and pipeline. So that is focused on specifically, so I'll take it from the bottom up really. Production process and pipeline is really about exactly that. It's essentially we create small teams of students on the course and effectively go through the whole production process of creating a small game, a vertical slice, like I mentioned previously. So it involves the creation of a game. It also involves the documentation of that game, from both a technical and design perspective. And it's also mainly about managing other people. So you're going to get all sorts of different things which mirror sort of the real world. And it's also it's kind of like I guess, an introduction to how people might see the junior and senior collaborative, for instance. I know it's in the first year. So you're going to get people who aren't there that day. You're going to get people that have dropped communications and that kind of stuff, because these are the kind of things that just happen from time to time with individuals, with human beings, right? So it's all about managing that process, and how do you manage workload, and how do you get things done? What kinds of frameworks are we going to use? So this is where we start teaching something called the Scrum framework, which is a methodology that's used in the games industry, which is a framework for having things like Scrum meetings, and there's product backlogs, which is the whole thing you need to create for your game, and there's something called a sprint backlog, which is we divide the sprints up into each week. So what aspects need to be created within the game, what needs to be completed by the end of sprint one. Then it's about reviewing that sprint, what needs to go forward into the next sprint, etc., etc., etc. So the main focus is the actual development of the project, and the actual game at the end of it is kind of what proves that pudding, and also how well that whole thing's been managed. That works in conjunction quite nicely, actually, with fundamentals of games development, because what that does, it introduces, the creation of a game within Unreal, the Unreal 5 game engine. And so what happens is that whilst in production process and pipeline, you could typically use any engine, really. We try to be as engine agnostic as possible. We do try to sort of go down the Unreal sort of route and suggest that, which works very well, because then both modules sort of bounce off each other. So within fundamentals of games development, it's about developing a game, and the emphasis is on the game, using Unreal as a tool for developing blueprint and various things that sort of underlie that game development. Those skills can then come over into production process and pipeline as well, and you can also get the additional support within production process and pipeline in order to reinforce those Unreal skills, and basically look at the managerial side of things. So again, those are two modules that work very, very well in tandem with each other. It's quite a good term there. Yeah.
Thank you. So moving on to level 5, the first module there is VFX for video games. So this is again more on the artsy side, but effectively looking at how we can use like particle systems and the like to make unique art styles for our games, or like projectiles and fire and visual effects. Ultimately, you will have all played games with fire. You'll probably all played games with like magic, and even things like wind going past, right? All these things can be particle effects. It's visual effects, right, for our games that really, really make them pop. Next up then is tools development. So this module is different to the one that's done on the programming course. This one is all done in Unreal Engine, and we look at making a tool for Unreal Engine to expand that engine, to give it a new functionality to be able to do more things effectively. But we cover similar topics. The lecture material is very similar, but the assessment strategy is different to these particular modules. Okay, and then moving on to our final year, we first up have the option between multiplayer games development or procedural content generation. So multiplayer games development is your introduction here to making the game from a multiplayer point of view. We look at the entire pipeline of the multiplayer suite in Unreal Engine, and this also covers, it does cover single local multiplayer as well, so like split screen, all that stuff, but obviously the primary focus is on the networked multiplayer, where we talk about kind of all of the networking implementations and how we have to replicate data across the network and these sort of things. And then the other module, the procedural content generation, is we take a look at how we can procedurally generate our worlds, our systems, that sort of stuff. So for instance, if you look at most open world games, they will have elements of procedural content within them, whether that is how some of the foliage is rendered, where some of the wildlife is, that sort of thing. And we really do a deep dive into kind of the PCG systems that are around that. We also look into things like level generation, so like randomized level generation and that sort of stuff. And then finally, the last module here is the mobile games development, where we kind of take all the sort of stuff that you've been learning thus far, but we put it into a mobile context. So you have to learn how to make a game that's fun, but also have to take into consideration the monetization model and the retention model and all of that sort of stuff to really keep the players sort of engaged consistently. Okay, and then finally, we have just very quickly the foundation year. So this year here is if you don't have the credits to kind of get onto our main branch, we have the foundation year where we introduce a bunch of the systems ready to go to get you really kick-started to go from our level 4 and onwards. So here, just very quickly kind of go through these. Introduction to Game Scholarship, we go over kind of how you would conduct research, how you write reports, and how you start that critical thinking like process. Programming foundations, we introduce the C# programming language, and you have to make a like a text-based game to kind of to go through that to understand kind of what programming is. We then introduce game design foundations, where we introduce engines again and just understand kind of what game design is, game feel, level design, that sort of stuff. And that's partnered with the Games Engine Foundation, where we go a little bit more into the actual engine itself. This is all summarized with the Introduction to Collaborative Enterprise, which is a group module, again, where you would partner up with the art students and the design students to make a small game and get you used to kind of working in a team of multiple disciplines. Okay, obviously that was a lot. We've just talked through kind of our main 3 courses and the foundation year. We've gone over kind of all the modules to give you an introduction to it. But let's talk a bit more about the department now. So one of the things that we're really proud of is the industry connections that we have here at Staffs. So you can see a scattergun of photos there for some of the events that we've done, but effectively we are consistently having guest lectures around to be able to offer that unique insight into a professional's day-to-day life, a project they've worked on, something that they're particularly interested in. You'll get that one-to-one kind of like knowledge exchange from those. Some of our modules have like live briefs, so this is where industry provides us with a task for our students to do. We align that to assignments. You would complete that task, then you'd get some feedback from industry on that. We also host things like Grads and Games. We have and the UK student conference as well. We've had great success with rookies. The other year we were ranked number 1 in the UK, where we are very much kind of up in that boundary right now. We do things like mock interviews, so all of our final year students get the opportunity to have an interview with the games industry. So this is where they either come on site or they're hosted virtually, depending on the studio, and they would do a one-to-one interview with you, but they would provide you with feedback on your performance, on your portfolio, and on your CV. We have our graduate exhibition show, which is actually about to start soon. It happens at the start of June. Every year. This is where all of our final years showcase their work, but we bring on a bunch of industry judges to kind of judge that work, but also to network and allow you to kind of ask them any questions or anything like that. Last year when we had our GradX, we had around about industry judges just in for games. And we also do an industry-led games jams as well, where we get industry to come around and do judging on that. So you can see we have a lot of industry connections here. Craig's also alluded to, we have our industry advisory panel, which isn't student-facing, but it means that all of our courses are aligned to industry needs, and that meets multiple times a year. Moving on, placements. So this is where some of our students are currently out on placement. And you'll be able to kind of apply to a placement. We have a lot of industry connections. We do have industry coming to us to kind of advertise those placements and lots of stuff, but we have a lot of built-in support preparing you to go and apply for a placement. We have a dedicated careers team that will make sure your CV, your portfolio, and everything is ready to go. Obviously, we have academics as well that will kind of do this for you. All of our assignments are led to having portfolio-ready content, and we work with our industry connections to make sure we have those opportunities available. We also have internal opportunities as well. So we have our own internal game studio, Oatcake Interactive, where we hire students on a placement basis to come and work for us on 3, 6, or 12 months basis, depending on the particular project. And those projects are worked into getting into kind of commercial releases. So This is an example of some of our graduate outcomes from last year. This is obviously just a selection of 2 from each course, just to kind of highlight this. But you can see there that we have a wide variety of studios that we work with, and you can see here that we've got a lot more kind of companies that our students kind of go to. We have really good success of our students going into the games industry, but also all of our courses are prepared to send you into adjacent industries, whether that's like software, for instance. And all this is supported by our industry connections, our mock interviews, and our employability schemes that we do to really make sure that you are ready for that graduate life. This is a little bit more kind of on GradX, but obviously we mentioned this, but it is a fantastic event where a lot of our students kind of just showcase that work, really get to network with industry, and actually we've had job offers offered at GradX as well because of the work that they've been shown. You can see here, GradX is a very big week. We take over one of the particular days, but it is a week-long event where you can actually go and look at some of the other work that some of the other students have been doing on some of the other courses as well. So it is strongly recommended that you do that. We have also got a Yuki membership, as I mentioned, that we host the Yuki conference every single year here at Staffs. That is actually open to the public. But our students get like first dibs to the tickets effectively. This last run in October time, and it was really good. We have keynote speakers, we have portfolio reviews, we have booths where recruiters from the games industry come to kind of just talk about their company, advise you, all of that sort of stuff. But we also do the Yuki Games Jam as well, which we've this is a winner from the other year, but we've actually just had 2 other winners in the last iteration of the Yuki Game Jam. We came 1st and 3rd as well, so it is something that we're really, really proud of. But we get to have our participation into that Yuki Games Jam every year because of the Yuki membership that we have. All our courses are as well Tiger accredited. Effectively means Tiger is the accrediting body for the UK games industry, and it effectively means that they think we're teaching the right things. That is judged by industry, by other academics as well. So it all sits on kind of a panel. It's something you have to kind of apply for, and we have to put kind of our student work forward, and we are accredited under this banner. But it does also allow us to have student wins as well. We get to participate in the Tiger Awards, where we do regularly win in these. So you can see here that we've got Fergus Griggs, which was one of our winners in the previous years for an outstanding piece of work where he made worms effectively and made the AI around that. It was really, really cool. We won last year for the industry collaboration that we do as well. But we also, actually on that one, there are a separate set of awards, which is more the industry awards. And last year we won UK Games Educational Institute as well. So we are currently the Tiger Educational Games Institution. And then we do also participate in the Games Republic as well, which is another competition that happens. And last year we won Best Team, and one of the games programming students won Best Games Technology as well for creating a non-Euclidean ray tracing framework using Vulkan. It was a really cool piece of technology that the student had made. But on coming to join us as well. Obviously, you're not just here for the subject. You're here for kind of the social lifestyle. There's plenty of things around. We have some nice social venues. We have great places to eat. But there's also a bunch of societies and clubs. So these are just a hand-picked selection of some of the ones that are more closely aligned to games. So you've got like the Myth Society, which is a bit more like Dungeons and Dragons. We've got Smash, which is all about Super Smash Brothers. Pokemon, all about Pokemon. Of Games Development Society, where students kind of get together to make games and deal have industry talks and all that sort of stuff. But there is a wide variety of socials and clubs that will align to your particular hobbies and interests. And if they're on the slim chance that there isn't one, you are supported to be able to kind of go and make those things. And there's a lot of support at the student union to make sure that you can find a society that speaks to you, and you can create that community around your likes and interests and all that sort of stuff.
I noticed you didn't talk about Fight Club
I didn't talk about Fight Club because we're not allowed to talk about Fight Club.
We're not talking about anybody who's familiar with that film, by the way. We haven't got some weird situation with something called Fight Club. It's not bare knuckle fighting. It's a fighting game club, by the way.
It is. Okay. So all of our classes work slightly differently depending on the particular module. However, every single module you are in for 6 hours a week. But that may that mixes up. So you may have 2 1-hour lectures and two 2-hour tutorials, or you may have 2 3-hour sessions, or you may have like a 2-hour and a 4-hour. It completely changes on the module which works best for that particular module in general. So it really allows you to get in depth with that particular topic because the timetable works around each individual module and kind of we understand what it needs to be to make those particular things work. All of our terms are 8 weeks long, and you submit in the 9th week. So there's 8 weeks of solid teaching, and then you get to have some support for that final week. Again, the assessments are different depending on the actual module and on the course, but all of the modules you will have to make something, and you'll have to kind of submit that artifact that you have created. You have to be coding things, but there will be elements of writing here, some critical reflection, doing literature reviews, writing reflective logs to our in-house forum, that sort of thing. But the assignments are built up around the module specific needs. We do also have a media store. So a lot of our facilities, so in the games, this is here we have the College Road, which is kind of where we're based. So the campus is based on 2 kind of roads which are super close to each other, but we're mainly based on College Road, and most of our games labs are in the Cadman building here, but we do have a couple in Mala. And we have this media stores right here, where you can actually go and loan out equipment for free, such as like for your headsets, like phones, if you want to do any like Android development, any cameras or anything like that. You can actually go in and loan those out if you want to kind of help you with your studies. Okay, that is everything from us. If you do have any questions, please feel free to email either myself or Craig. Our email addresses are just on screen there. But yeah, thank you very much for listening.